Let z be a complex number given in polar form, namely r times cis theta, and let n be an integer. The Moivre formula states that the nth power of z is given by r to the n times cis of n times theta. Here, n does not need to be non-negative, so you can use this formula to compute z to the minus 100, for example. This formula simplifies computing powers of a complex number, provided you have the polar form of the complex number. So let's take a look at an example. Suppose that z is 1 plus I. What is z to the 10? Right now, z is in rectangular form, so we have to convert it to polar form before we can use the Moivre's formula. But there's really nothing that stops us from computing z to the 10 directly. We just need to multiply 10 copies of 1 plus I. So what is the polar form of this? You can first draw a little sketch on where this number is on the complex plane. So the real part is 1 and the imaginary part is 1. So z is somewhere here. And we can easily calculate the modulus of z, and that's just the square of 1 square plus 1 square, and that's square of 2. And what about the argument? If you draw the triangle, the height is 1 and the base is also 1. So the argument of z is going to be the arctangent of 1 over 1, that's 1, and the arctangent of 1 is pi over 4. So that gives us z equal to square root of 2 times cis pi over 4. And that means z to the 10 is given by square root of 2 to the 10 cis of 10 times pi over 4. And simplifying this gives us 32 times cis of 5 pi over 2. But now 5 pi over 2 is bigger than 2 pi. So we can bring this angle to within 0 and 2 pi by subtracting 2 pi. And that will give us just pi over 2. Now, what is cosine pi over 2? Cosine pi over 2 is 0, whereas sine of pi over 2 is 1. So cis of pi over 2 is simply I. And so 32i is z to the 10th power. Now, as an exercise, you can try calculate z to the 15th power and see what it is.